How much does riding at altitude affect your performance? What can you do to prepare for riding at altitude? And can altitude training improve your performance at sea level? This is what we'll be getting into today by taking a look at the science. I'll also be touching on simulated versus real altitude, how much time at altitude you need to acclimate, genetic differences in how we respond to altitude, heat training and how that relates to altitude training, and nutritional considerations that you need to take into account when going to altitude. Welcome back to another video. Altitude training is pretty common amongst pro cyclists who are looking for every advantage they can get. But it's also something that amateur cyclists need to take into consideration because oftentimes cycling events are held in the mountains at high altitude. The stop sign sprint on the Tuesday night group ride is at the top of this hill that's at an elevation of like 200 feet. Does that count? I mean, I just need every advantage I can get. Let's start with how riding at altitude affects your performance. How much will riding in the thin air slow you down? Well, it actually doesn't slow you down at all. In fact, you're actually able to go faster at altitude. That is, if you were able to put out the same power. As altitude increases, there are fewer gas molecules in the air, meaning that it's less dense and you can travel through it faster. How much faster? If we head over to bikecalculator.com, we find that if you were to do a 40K flat time trial at 250 watts at sea level, and then the same time trial at the same power at 2,500 meters or a little over 8,000 feet elevation, you would go almost 7.5 minutes faster at altitude. This is an impressive improvement, but anybody who's actually ridden at 2,500 meters knows that you can't put out the same power. So what kind of power loss can you expect at altitude? This chart by Joe Friel using data from altitude cycling studies shows that aerobic power can drop roughly 12 to 16% at 2,500 meters based on whether or not you're acclimated. Interestingly enough though, for our flat TT example, even with the drop in power, you'd still be faster at an elevation of 2,500 meters than you would at sea level. Roughly 69.8 minutes at sea level versus 66.4 minutes at altitude, even with the loss of power. And this is assuming you were producing power 100% aerobically. Of course though, there will be an altitude at which your power drops too low and the lower air density won't make up for the loss of power. Where does that point lie? Going back to the study on the hour record, they found that the optimal elevation for an hour record would be 2,500 meters for acclimatized riders and 2,000 meters for unacclimatized. And in fact, many of the early records set by Merckx and Mosier were set at altitude in Mexico City. So does altitude hurt your performance? Well, yes and no. Your power will certainly be lower, but if you're riding on flat terrain, as long as you're not at too high of an elevation, you'll actually go faster at altitude. That being said, as soon as you hit some steep climbs and your speed drops down, aerodynamic drag becomes less of a factor, and the advantage shifts in favor of low altitude as far as speed is concerned. Using the same rough numbers as before, you'd be a little over 6 minutes slower on a 10K 7% grade climb at an altitude of 2,500 meters. That's all well and good, but altitude has other performance enhancing effects other than that it makes it easier to break wind. Altitude camps and simulated altitude are pretty common amongst top level competitors for the physiological benefits they provide, even when training for events at low altitude. So the question is getting out to high altitude worth it for the potential performance improvement? It's well established that acclimation to altitude will improve your performance at altitude. We can see here there's about a 5% increase in VO2 max at altitude after acclimation. If we look to the top left side of the graph though, we can see that at sea level, there seems to be very little difference to none at all in VO2 max between acclimated and not acclimated. So, will spending time at high altitude actually affect your performance at sea level? As this review on altitude training for performance at sea level points out, there are both advantages and disadvantages to training at altitude, and some of these disadvantages may cancel out any performance benefit. In their conclusion, they state that scientific evidence to support the use of altitude training to improve sea level performance is equivocal. From this review article on altitude and cycling performance, results from 5 different research groups that have used controlled study designs indicate that continuous living and training at moderate altitude does not improve sea level performance of high level athletes. However, recent studies from 3 independent laboratories have consistently shown small improvements after living in hypoxia and training near sea level. And this brings us to different altitude training protocols. While living at high altitude and training at high altitude will improve your performance at high altitude, there's little evidence that it'll improve your performance when you go back down to low altitude. This is likely due to the fact that your training intensity at altitude is reduced. But could living at high altitude and training at low altitude be the best of both worlds? This is the theory behind live high, train low. Live high? Ooh, I like where we're going with this. Not that kind of high, dude. This study put the live high, train low theory to the test. They set up a control group that trained and slept near sea level, and an experimental group that trained at sea level but slept at a simulated altitude of 3,000 meters. They found that muscle buffering capacity increased and submaximal VO2 decreased, suggesting improved efficiency in the live high, train low group. This paper on altitude training for marathons stated that based on published mathematical models of marathon performance, a marathoner who performed live high, train low altitude training could experience an improvement of nearly 8.5 minutes, or roughly 5% over a marathon race. So this idea that you should live at high altitude and train at low altitude does seem to have some merit. Unfortunately, it's often extremely impractical. Very few of us live on top of a mountain and can ride to the bottom every day to do our ride. In fact, it's usually the opposite if you do live near mountains. People often live in the valley and then head to the mountains to do their ride. Unfortunately, from a physiological perspective, this is the least effective strategy. This review on altitude training for elite athletes looked at the live high, train low, and live low, train high approach. They found that live high, train high, and live high, train low may increase exercise performance in some, but certainly not in all. The same cannot be said for living at low altitude and training at high altitude, and they even go as far as to say there is no need for further research on the live low, train high method. This is where simulated altitude like altitude tents, altitude chambers, altitude room conversions, and intermittent hypoxia training come in. They all simulate conditions at high altitude, so you can live high and train low. And many studies on altitude training use simulated altitude, not real altitude, and show promising results, so there is evidence that they do work, although research into the effects of simulated altitude versus real altitude is extremely limited. With many of these simulated altitude solutions, though, you aren't spending all day at altitude. With the tents and chambers, for example, you're spending 6 to 10 hours a day at night while you sleep. With intermittent hypoxia training, you might be spending 1 to 2 hours a day. Is this really enough time, though, to get the necessary adaptations? This study had subjects spend 8 to 10 hours a night at a simulated altitude of 3,000 meters for 23 nights. They found that hemoglobin mass was no different after the altitude training. This study used a very similar protocol, however, they had subjects spend 14 hours per day at altitude. And sure enough, there was a 3.3% increase in hemoglobin mass. The study concluded that greater than 12 hours a day of altitude exposure is needed for adaptation. Given that most people don't sleep for 12 hours a day, this poses a problem for the altitude sleeping solutions. That being said, if you have less time to spend at simulated altitude, increasing the altitude may help. For example, these two meta-analyses found that for an altitude of 2,000 to 2,500 meters, more than 20 hours a day for a period of no less than 28 days is needed to enhance performance. Bump that altitude up to 2,500 to 3,500 meters though, and you may be able to get away with a minimum of 9.5 hours daily for 2 weeks before competition. You may be able to get away with spending less time at altitude if the altitude is higher, but this comes with its own set of drawbacks, like reduced sleep quality and poorer recovery. There is a form of simulated altitude training that you don't have to use while you sleep though, and it's called intermittent hypoxic exposure or intermittent altitude exposure, in which exposure time is much lower, usually less than 4 hours per day, but to compensate for this, the altitude is much higher. Sounds a little more convenient, but does it actually work? This study on intermittent altitude exposure had subjects spend 4 hours a day, 5 days a week at a simulated altitude of 4,300 meters. Sure enough, those that received the altitude treatment saw an improvement in their time trial performance at altitude. However, further study into intermittent hypoxic training doesn't look as promising. For example, this study found no significant effect of intermittent hypoxic training on performance. The main difference with this study, however, is that the sessions only lasted an hour instead of 4. Further studies into intermittent hypoxic training all come to the same conclusion, which is that it has no effect. However, none of them had subjects exposed for 4 hours per day like in the first study. What can we conclude from all this research on live high, train low, and simulated altitude? Well, first, if you think that going to the mountains for a couple hours and riding your bike is going to do anything for you in terms of altitude acclimation, you're sorely mistaken. And this is also why those altitude training masks that are meant to be worn during exercise are complete BS. Yeah, but wearing one to the CrossFit gym to look like a total badass, that makes sense, right? You simply don't spend enough time while riding at altitude to acclimate, and your training quality will suffer. Next is that acclimation will help your performance at altitude. There's no question, whether you go with live high, train high, or live high, train low. But remember that acclimation takes a lot of time, as in the majority of the day, every day for weeks in a row. You may be able to get away with spending less time at altitude if you're at a higher altitude or simulated altitude, but that carries its own set of drawbacks. You likely need at least 2 weeks at altitude to acclimate, and more is better. When you first arrive at altitude, you may be feeling some negative effects, so it's often a good idea to reduce the intensity of your riding, at least for a little bit. This is also why it's ill-advised to show up to a high altitude event a couple days before the event, because you'll be feeling all of the negative effects without any acclimation. Although data on this theory is actually mixed. For example, this study found that 50-minute time trial performance on the third day of altitude exposure was actually better than on the first day. When it comes to using altitude training to improve your sea level performance, results are mixed. However, if you do decide to go that route, live high, train low is your best option. But keep in mind that the benefits are small and not guaranteed. Going back to this review, they state that while living at altitude and training near sea level may be optimal for enhancing the performance of a competitive cyclist, much further research is required to confirm its benefit. If this benefit does exist, it probably varies between individuals and averages little more than 1%. That's right, we're talking about maybe getting a 1% performance improvement. And when you put it in those terms, it really makes dropping thousands on one of these forms of simulated altitude one of the most expensive marginal gains that you can buy. But hey, if you're a pro or every second matters to you, it might be worth it. If not, though, I'd save your money. Yeah, tell me about it, man. I could take that money that I would have spent on an altitude tent and buy a whole new bike, or one pair of Rafa bibs. Yeah, I'll go with the second option. Another important piece of the puzzle that I haven't touched on yet is individual variability. It's hard to give a blanket statement like, if you're at this altitude, you need to spend this much time, and if you're at this altitude, you need to spend this much time, because the truth is, it varies between individuals. There are genetic differences in how we react to altitude. This review article on individual responses to altitude states that some athletes are clearly more negatively affected during exercise in hypoxia than other athletes. In this article, the authors tried to take a crack at what dose of altitude is enough. They state that the individual variability of responses to even the best of living high, training low strategies has been great, and that more research needs to be done on how to enable individualized prescriptions of altitude exposure to optimize the performance of each athlete. This study even pinpoints the gene that may be responsible for this variation. Basically, one altitude training prescription will not work for everyone. Some people will simply need more exposure, and some people will react differently than others. This is why cycling events at altitude really throw a curveball at competitors. The strongest rider at sea level may not necessarily be the strongest rider at altitude. All of that being said, there may be some things that you can do to try to minimize the negative impact that altitude has on you and ease the acclimation process. For example, heat training has become popular as a poor man's altitude training, the theory being that many of the adaptations that you make to heat training are similar to the ones that you make with altitude training. Well, kinda. From this article on heat and altitude, altitude training can provide an increase in oxygen carrying capacity, a more efficient use of oxygen, and a better ability to tolerate anaerobic metabolism. Heat training has the ability to increase plasma volume and reduce cardiovascular and thermoregulatory strain. That being said, they recommend focusing on the intervention most relevant to competition. So train in the heat for a hot event and train at altitude for an event at altitude. Shocker. The truth is that right now there's simply a lack of evidence on how heat training affects altitude performance. This article on the topic states that it's unknown whether prior heat acclimation could alter exercise capacity at altitude in humans. However, experiments using animals suggest that acclimation to one environmental stressor, like heat acclimation, could enhance adaptation to various other stressors, like altitude, without any pre-exposure to that specific stressor. But further research is needed. One thing that you can do to facilitate the acclimation process is make sure that your nutrition is on point and that you're getting enough of a few key nutrients. From this review on dietary recommendations for cyclists training at altitude, they state that fluid intake should be roughly 10 liters daily for cyclists with heavy training loads. However, monitoring fluids is important because overhydration has actually been shown to decrease adaptation. You may also want to increase your energy intake by consuming more carbohydrates. This may be easier said than done though, because altitude often suppresses one's appetite. Additional antioxidant supplements are not recommended as they could hinder the adaptive processes related to aerobic endurance. This review article confirms this, stating that the safest way to address the possible increase in oxidative stress associated with high altitude exposure is via the consumption of antioxidant-rich foods rather than high-dose antioxidant supplements. Basically, the advice is exactly what I've been preaching on this channel. Get your antioxidants from real food, not only to help with altitude acclimation, but also to improve recovery. That being said, iron intake is very important to monitor at altitude, and you want to be taking in at least 100 milligrams per day. Vitamin D is also important to consider, and supplementation may be required, especially in winter months. So basically, the things to keep in mind with your nutrition at altitude are as follows. Drink enough fluids, but don't overdo it. Increase your food take mainly through eating more carbohydrates. Consume a well-balanced diet with plenty of antioxidant-rich foods. Don't rely on antioxidant supplements. And finally, make sure that you're getting in enough iron and vitamin D. Thanks for watching. I hope you found this information helpful. If you did, be sure to give this video a like, comment down below what topics you'd like to see me cover in the future, and subscribe